All right, we're in a helicopter flying handbook. This will be chapter 9, page 3 of 20. This will be hovering. Hovering is a maneuver in which the helicopter is maintained in nearly motionless flight over a reference point at a constant altitude and on a constant heading. Technique. To maintain a hover over a point, use side view and peripheral vision to look for small changes in the helicopter's attitude and altitude. When these changes are noted, make the necessary control inputs before the helicopter starts to move from the point. To detect small variations in altitude or position, the main area of visual attention needs to be some distance from the aircraft using various points on the helicopter or the tip path plane as a reference. Looking too closely or looking down leads to over-controlling. Obviously, in order to remain over a certain point, know where the point is, but do not focus all attention there. As with a takeoff, the pilot controls altitude with the collective and maintains a constant RPM with the throttle. The cyclic is used to maintain the helicopter's position, the pedals to control heading. To maintain a helicopter in a stabilized hover, make small, smooth, coordinated corrections. As the desired effect occurs, remove the correction in order to stop the helicopter's movement. For example, if the helicopter begins to move rearward, apply a small amount of forward cyclic pressure. However, neutralize this pressure just before the helicopter comes to a stop, or it will begin to move forward. After experience is gained, a pilot develops a certain feel for the helicopter. Small deviations can be felt and seen, so you can make the corrections before the helicopter actually moves. A certain relaxed looseness develops, and controlling the helicopter becomes second nature rather than a mechanical response. Common errors: tenseness and slow reactions to movements of the helicopter. Failure to allow for lag in cyclic and collective pitch, which leads to over-controlling. It is very common for a student to get ahead of the helicopter due to inertia. It requires some small time period for the helicopter to respond. Confusing attitude changes for altitude changes, which results in improper use of the controls. Hovering too high, creating a hazardous flight condition. The height velocity chart should be referenced to determine the maximum skid height to hover and safely recover the helicopter should a malfunction occur. Hovering too low, resulting in occasional touchdown. Becoming overly confident over prepared surfaces when taking off to a hover. Be aware that dynamic rollover accidents usually occur over a level surface. All right. This will be a hovering turn we'll go into. A hovering turn is a maneuver performed at hovering altitude in which the nose of a helicopter is rotated either left or right while maintaining position over a reference point on the surface. Hovering turns can also be made around the mast or tail of the aircraft. The maneuver requires the coordination of all flight controls and demands precise control near the surface. Pilots should maintain a constant altitude, rate of turn, and RPM. Technique. Initiate the turn in either direction by applying anti-torque pedal pressure toward the desired direction. It should be noted that during a turn to the left, more power is required because left pedal pressure increases the pitch angle of the tail rotor, which in turn requires additional power from the engine. A turn to the right requires less power. On helicopters with a clockwise rotating main rotor, right pedal increases the pitch angle and therefore requires more power. All right. As the turn begins, use the cyclic as necessary, usually into the wind, to keep the helicopter over the desired spot. To continue the turn, add more pedal pressure as the helicopter turns to the crosswind position. This is because the wind is striking the tail surface in the tail rotor area, making it more difficult for the tail to turn into the wind. As pedal pressure increase due to crosswind forces, increase the cyclic pressures into the wind to maintain position. Use the collective with the throttle to maintain a constant altitude and RPM. After the 90-degree portion of the turn, decrease pedal pressure slightly to maintain the same rate of turn. Approaching the 180-degree or downwind position, anticipate opposite pedal pressure due to the tail moving from an upwind position to a downwind position. At this point, the rate of turn has a tendency to increase at a rapid rate due to the tendency of the tail surfaces to weather vane. Because of the tailwind condition, hold rearward cyclic pressure to keep the helicopter over the same spot. The horizontal stabilizer has a tendency to lift the tail during a tailwind condition. This is the most difficult portion of the hovering turn. Horizontal and vertical stabilizers have several different designs and locations, including the canted stabilizers used on some Hughes and Schweitzer helicopters. The primary purpose of the vertical stabilizer is to unload the work of the anti-torque system and to aid in trimming the helicopter in flight should the anti-torque system fail. The horizontal stabilizer provides for a more unstable CG range. center of gravity range and aids in trimming the helicopter longitudinally. Because of the helicopter's tendency to weather vane, maintaining the same rate of turn from the 180 degree position actually requires some pedal pressure opposite direction of the turn. If a pilot does not apply opposite pedal pressure, the helicopter tends to turn at a faster rate. The amount of pedal pressure and cyclic deflection throughout the turn depends on the wind velocity. As the turn is finished on the upwind heading, apply opposite pedal pressure to stop the turn. Gradually apply forward cyclic pressure to keep the helicopter from drifting. Control pressures and direction of the application change continuously throughout the turn. The most dramatic change is pedal pressure and corresponding power requirement necessary to control the rate of turn as the helicopter moves through the downwind portion of the maneuver. Turns can be made in either direction. However, in a high wind condition, the tail rotor may not be able to produce enough thrust, which means the pilot cannot control a turn to the right in a counterclockwise rotor system. Therefore, if control is ever questionable, first attempt to make a 90-degree turn to the left. If sufficient tail rotor thrust exists to turn the helicopter crosswind in a left turn, a right turn can be successfully controlled. The opposite applies to helicopters with clockwise rotor systems. In this case, start the turn to the right. Hovering turns should be avoided and wind strong enough to preclude sufficient aft cyclic control to maintain the helicopter on the selected surface reference point. When headed downwind, check the flight manual for the manufacturer's recommendation for this limitation. Common errors: failing to maintain a slowed constant rate of turn, failing to maintain position over the reference point, failing to maintain RPM within normal range, failing to maintain constant altitude, failing to use the anti-torque pedals properly. All right, and we'll go one more. This will be hovering forward flight. Forward hovering flight is normally used to move a helicopter to a specific location, and it may begin from a stationary hover. During the maneuver, constant ground speed, altitude, and heading should be maintained. Technique: before starting, pick out two references directly in front and in line with the helicopter. These references points should be kept in line throughout the maneuver. Begin the maneuver from a normal hovering altitude by applying forward pressure on the cyclic. As movement begins, return the cyclic toward the neutral position to maintain low ground speed, no faster than a brisk walk. Throughout the maneuver, maintain a constant ground speed and path over the ground with a cyclic, constant heading with anti-torque pedals, altitude with the collective, and the proper RPM with the throttle. To stop the forward movement, apply rearward cyclic pressure until the helicopter stops. As forward motion stops, return the cyclic to the neutral position to prevent rearward movement. Forward movement can also be stopped by simply applying rearward pressure to level the helicopter and allowing it to drift to a stop. Common errors: exaggerated movement of the cyclic resulting in erratic movement over the surface, failure to use proper anti-torque pedal control resulting in excessive head change, failure to maintain desired hovering altitude, failure to maintain proper RPM, failure to maintain alignment with the direction of travel. Yeah. So what time we at? 8:25. We'll go ahead and hold on there. We made it to page 5, hovering forward flight, went into page 6. All right, so we'll head up there on chapter 9, page 6 of 20. See ya.